Hi viewers, this video explains how to insert the data into the queue by using Java programming. The queue implementation using array is very easiest among the implementation of queue types. Then, which is keeping the track of number of data inside the queue by using the index. The first element is denoted by using the front variable, and the last element is denoted by using the rear variable. So here the size of the queue is given. The size of the queue is 3 elements. Then front pointer index value is 0. Then rear pointer index value is 2. This is the representation of queue. Now I want to insert one element at end of the queue. So now that operation is called enqueue. The element is entered into the queue and stored in the free space. Then the size is incremented by 1. So here uh, earlier the front pointer is denoting the index number 0, rear is denoting the index number 2. Now the number 2 is inserted into the free space. So earlier here this is the structure of the queue. Now here I want to insert the new value 2 into the free space. So always the new data will be assigned into the free space of the queue at back end. That is the rear pointer. Now rear pointer is incremented by 1, and here the rear pointer is incremented by 1. Then the 2 is stored here. So rear will be now location 2 plus 1 3. So in the location 3 the new data item 2 is stored. So rear pointer is now changed, updated. So this is done by using the Java programming. The method name is the enqueue. That means inserting the new data into the queue. I am passing the data item into the method. Now first I am checking the given queue is full or not. If my queue is this one, just I am checking my queue is full or not. If my queue is full, then I can say my queue is full. Otherwise, if rear equal to maximum minus 1, suppose here I am having the data 7 6 8 10. The first location is first data is indicated by the front variable, and last data is indicated by the rear variable. So now if my rear is equal to maximum minus 1, what is the maximum size? Maximum size is here 4. Okay, maximum size is here 4, the maximum size of the queue. So now we are checking maximum size is 4 minus 1. The rear index is denoting the 3. So 3 equal to 4 minus 1 3. So if it is equivalent, then we have to make that queue into null. We have to make the queue into null because our queue is full now. Our queue is full now. We have to make that into null if both are matching. If the maximum size is equivalent to the rear, that means queue is full. You cannot insert the data. So you have to make the queue into empty. Then we can insert the new item. So now if you rear is minus 1, then your queue will become like this. If your rear is minus 1, that means your rear is minus 1, then it is the empty queue. Now the rear will be incremented by 1. So that's what you look at, that pre-increment. Rear is incremented by 1. Rear equal to rear plus 1. Now rear is minus 1 plus 1 will be 0. So now rear will be 0. Okay, so it is indicating the 0th index. Now I am assigning the queue underscore array of rear. Rear value is now 0. In the 0th location I am inserting my new data item. So if my new data item is 5, then 5 will be stored here. Now rear is pointing the 0, already front is pointing the 0. So both are pointing the 0th location. Then now current size is incremented by 1. Initially the current size is assigned with 0. Now again I am going to assign one more value, insert one more value, suppose 2. Now I am checking my queue is full or not. No, you look at that, my queue is not full. Then I am checking rear equal to maximum minus 1. So rear equal to maximum minus 1. This is also false. Rear is now the 0 is the rear. 0 is the rear. So since 0 is rear, so 0 equal to, what is the maximum size? Maximum size is 4. So 4 minus 1 equal to 3. So 0 equal to 3, which is false. So this block will not execute. Now coming to the next line. So the array is incremented by 1. Look at that. So now the second iteration, second time, for second element, rear equal to rear plus 1. So here the rear is now 0. So 0 plus 1. So the rear value become 1. So here q under, so this line is now q underscore array of 1. So now q underscore array of 1. In this location, I am going to assign the new data item value. So new data item value is 2. So like this, we can insert the new data on the back end by using the rear pointer. So now rear is 1, so which is updated. So this is becoming the rear. So this is the procedure to insert the data into the queue by using array implementation. Thanks for watching.